Okay, lesson number 6. This is a continuation from lesson 5 with the factoring of polynomials, only we extend the factoring to situations where we have a coefficient in front of the first term. So instead of it just being x to the power of 4, it's now 3x to the power of 4. It really does not change a lot of things except for what my factors are going to be. It changes some of my possibilities. So if we look at the factors of the polynomial, p of x equals 15x squared minus 34x plus 16 are 3x minus 2 and 5x minus 8. What are the zeros then of this function? If these are the factors, what would the zeros then be? 2/3 and 8/5. So we'd be letting each factor be equal to 0. It says, what do you notice about the constant term in the polynomial, which is 16, and the constant term in the factors? So if I look at the constant terms in the factors, which are -2 and -8, what do you notice?
Multiply them together equals 6.
Okay. So -2 times -8 equals 16. What's the leading coefficient in my polynomial? 15. And what are the leading coefficients in the two factors? 3 and 5. And what do you notice about 3 and 5?
3 times 5 is 15.
Okay. And in the part 4, it says, how do the zeros in the coefficients relate to the polynomial? So how do the zeros relate to the coefficients? So if I look at my two numbers, my 2/3 and my 8/5, how do they relate? Well, look at the 8 and the 2. What are the numerators? What do the numerators relate to?
The constant.
The constant. And what do the denominators relate to? The leading coefficient. So if we look at question B, B gives us a third degree polynomial, 10x cubed plus 81x squared minus 298 plus 231. It says state the zeros of the polynomial function. These are the factors. So if those are my factors, what are my zeros? So 3/2, 7/5, and -11. What do you notice about the constant term in the polynomial and the constant term in the factors? So what's the constant term in the polynomial? 231. And what are the constant term in the factors?
33, -7.
And what do I notice about those three numbers compared to the 231? If I multiply them together, it gets me 231. What is the leading coefficient of this polynomial? 10. And what are the leading coefficients of the factors?
5 and 2. And 1.
5, 2, and 1. And when I multiply them together, it equals 10. So it says, how do the zeros relate to the coefficients in the polynomials? So again, does it work like it did before? Do the numerators of the zero correspond to the constant, and do the denominators correspond to coefficient? Okay, so the numerators give me the constant, and the denominators give me the leading coefficient. So from there, we get this rational zero theorem. The rational zero theorem says that the zeros of an integral polynomial function p of x are of the form p over q, where the numerator is a factor of the constant term and the denominator is a factor of the leading coefficient. So if I look at the following page with the polynomial 5x cubed minus 51x squared plus 55x minus 9. If I look at all the factors of the constant term, I've got 1, 3, and 9, positive or negative. The leading coefficient of 5, the factors are 1 and 5. So then my 0, p over q, is factors of the constant term over factors of the leading coefficient. So this could give me positive or negative 1, positive negative 3, positive negative 9, positive negative 1/5, 3/5, or 9/5. And then from there, I can figure out which one of those was a 0 and then use that to start my synthetic division. So it says use the potential zeros above to list the potential binomial factors in the form of ax minus b, where a is a natural number and b could be an integer. So what that means is if I have a 0 of positive or negative 1, what would my factor be? Right. And for 3, my factors would be? And then I have the same thing for 9. If I have a 0 of 1/5, what's the factor going to be?
5x over this one.
Right. And then 5x plus 1. What's my 3/5 going to give me?
5x minus 3x plus 3.
And then my 9/5 would give me 5x minus 9 and 5x plus 9. So question B says show that x equals 1 is a 0 of p of x and then determine all of the zeros of p of x. So to show that x equals 1 is a 0, I can show that it's a factor. And so I can use synthetic division to show that my remainder would equal 0. That's how I show that it's a factor. So 1 goes to the outside, and then I have 5, negative 51, 55, and 9. And if I do this correctly, I should get 0 for my remainder. So I drop the 5. Negative 51 plus 5 equals and then negative 46 times 1 is negative 46 plus 55 is 9. Well, this should have been a negative 9. There we go. 1 times 9 is 9 plus negative 9 equals 0. So now I have 5x squared minus 46x plus 9 is what is my other factor. So I go to solve this. I have my x minus 1 from this one. and then this 5x plus 9. I can solve this a couple of ways. I can do decomposition, or I can do inspection. But before I look at it, to try to figure out whether or not I could factor this, two numbers that multiply to 45 and add to negative 41. Is that possible to actually do? Could I have two numbers that multiply to 45 and added to negative 46? It'd be 45 and 1. So because it's possible, it means that it's factorable. So now I can try doing my factoring. I can factor by inspection, or that kind of somewhat inspection that I showed you last year, because this is a prime number. So the only way that I can get 5x squared is to multiply 5x and x. And then this negative 46, when I was looking at this 45 and 46, the two numbers I was coming up with was a 45 and a 1. Well, what's going to give me the 45? What would I put here to get the 45? 9. There's my 1. Because the only way that I can get 9 is 9 times 1. This is a minus, so these would both be minuses. So now I have this factored. So then what are my zeros? I already have 1 as a 0. What are my other two zeros? 1/5 and 9. So question C, where it says solve the equation, solving the equation, which is determining the roots are the same as the zeros. So x would be equal to 1, 1/5, and 9. Okay? So if we look at class example number 2, it says determine all real solutions to the equation 2x cubed minus x squared minus x minus 3. So when I'm thinking of potential factors or potential zeros, the numerator is equal to what? The constant. So my constant is 3. So what are my potential factors for 3? 1 and 3. So I'm going to have 1s on the top and I'm going to have 3s on the top. My denominator are my factors from what? And the leading coefficient is 2. So I'm going to have 2 and 1. So my bottoms could be 2 and 1. So that means I'm going to have a 1 and a 2, a 3 and a 2, and then 1 over 1 and 1 over 3. And then these are all going to be positives and negatives. So you may find it easier to put the 1 and the 3, maybe not making it look like 13, but the positive 1 and positive 3 over the positive 1 and the positive 2. And then sorting it out so that you can list all of your factors. Okay? So now when I'm checking potential zeros, start with the whole numbers or the integers first. Start with the positive and negative 1 and the positive and negative 3. So if I use the remainder theorem and I was to figure out P of 1, I get 2 times 1 cubed, which is 2, minus 1, minus 1, minus 3. What does that equal? Minus 1 is 1, 1 minus 1 is 0, 0 minus 3. So is 1 a potential 0? No. So then try negative 1. So negative 1 cubed is Negative 1 times 2, negative 2. Then I've got negative 1 squared, which would be positive 1. Negative of negative 1 would be a positive 1 minus 3. What do I get this time?
Negative 5.
Negative 5. So then I could go on. And there's quite a few factors there, so I'm always looking for a shortcut. So if we go back to what I showed you the other day, and we grab our calculator, this is how we can shortcut it. Because I don't want to graph this, but I do want to find a way that will make this easier. So if I put this equation in there, 2x to the power of 3 minus x squared minus x minus 3. Then what I'm going to do is I'm going to go to my table set. So I'm going to go second window, which is my table set. And instead of auto, I'm going to put it on ask. And then I control what I put in. So now if I go to my second table, it's blank. So now I can start putting in those potential zeros. I have positive 1. I have negative 1. I have positive 3. I have negative 3. So I still haven't hit a 0 yet. Now I can look at my 1/2. 1/2, negative 1/2. Now I'm at 3/2. So 3/2, there's my 0. So my potential 0 becomes 3/2. And so I'm still, in a sense, doing this algebraically. I'm just making it shorter because I don't want to spend all of my time doing my basic math. I want to spend my time actually factoring this. So I now have that my 0 of 3/2 will be my 0. So now I can do the synthetic division. Negative 1, negative 1, negative 3. So if I take 3/2 and multiply it by 2, what do I get?
3.
3. If I take negative 1 and I add 3, I get, multiply that by 3/2 and I get, add and I get 2, multiply again and I get 3, and there's my 0. So now I have the factor 2x squared plus x plus 2x plus 2. So my factored polynomial right now looks like this. It's got my 3x plus 2, which as a factor, what would my 3 over 2 be? Not 3x plus 2. What would this be as a factor, my 3/2? 2x minus 3. And then I have this 2x squared plus 2x plus 2. What can I factor out of each of these?
2.
A 2. So I can take out a 2, and now I have x squared plus x plus 1. Can you think of two numbers that multiply to 1 and add to 1? The only way I'm going to get them to add to, there's no way I can get them to add to 1 and multiply by 1. So if I can't do this by inspection, what am I left with?
I didn't know.
Sorry, the look on Addison's face was like, oh no, really, the quadratic formula. So x equals negative b, which would be negative 1, plus or minus the square root of b squared minus 4ac divided by 2a. So what is 1 squared?
1.
And 4 times 1 times 1? So what's 1 minus 4? Negative 3. So now I've got negative 1 plus or minus the square root of negative 3 over 2. Do I have any problems at this point? The negative 3. I can't square root a negative 3, which means this is a non-real solution. And we do not deal in non-real solutions. So the only real solution